Good morning, students. Today we are going to discuss an important formula of 12th physics, which is known as Lenz's formula and its derivation. In your 10th class, you discussed about Lenz's formula, and you may know that it is a relation between focal length, object distance, and image distance. We are having three quantities. F is known as focal length, we represent it by small f. V is known as image distance, it is indicated by V, and U is known as object distance, which is indicated by U. In 10th level, we only write this formula, but we don't talk about its derivation. But in 12th physics, we have to find out how can we calculate this, that 1 upon f is equal to 1 upon v minus 1 upon u. So in today's class, we are going to obtain this by this ray diagram. Here I draw a simple ray diagram which is related to a convex lens. We are having convex lens here. It is its principal axis, this line, and we have indicated its f1 to f1 focus point and its double to f1, and this side also we have f2 and 2f2. First of all, if we place an object AB between its focus point and 2f, f and 2f, then we have drawn here two rays. We know that to form an image, we are having at least two rays. Then our first ray, which is parallel to the principal axis, and after reflection from this lens, it is passing through focus point. And for image formation, we are having second ray, which is passing through its optical center, and both these rays after refraction coinciding or intersect each other at this point. So here E dash B dash will produce image of this object A. And if we are placing object between f and 2f, then in theory we also know that image will form after 2f point. So here AB will its image. In this process, we also indicated the terms we are using to derive this formula, which is Lenz's formula. Here OA, distance from optical center to A point, it is known as object distance. So object distance is indicated by U, and here we place a negative sign, which is due to sign conventions. Due to sign conventions rules, U is always with negative sign for a convex lens. OA dash, from point A to O to A dash, it is known as image distance, and we are indicated it with symbol V. Also OF2, from O point to F2 point, it is focal length of this convex lens, and we indicate focal length by small f. And this term we will use in further derivation, so we write here, that is discussed afterward. So to start this derivation, in this ray diagram, we are taking two triangles. I am writing here in triangle. The first triangle we are ratio of sides in both these triangles. The ratio of the sides are always equal to each other. So in first triangle, that is OAB, if we take any one side of it, for guess its AB side, and the second triangle is A dash B dash. The ratio of any two sides will be equal to ratio of another any two sides, which is we are taking here. The first side we are taking OA, then similarly the secondary triangle will have its OA dash. So AB upon A dash B dash will be equal to OA upon OA dash. We denote it by equation 1. After that, we are indicating a line here, and we indicate this point as a point M. And you can see that this is also becoming another angle. So triangle MOF2. So in second process, we are taking both these triangles. The first triangle is MOF2, and its similar triangle will be F2A dash A dash. F2A dash to B dash. These triangles are also similar triangles, so we can apply this property as well also here. So in this triangle, first triangle, the OM side of first triangle will be in the ratio of A dash B dash, and its second side OF2 will be divided by the another side of second triangle, which is A dash F2. A dash F2. This will be our second equation. Then in second equation, if you see this ray diagram, you will observe that the distance of AB will be equal to distance of OM or MO, because principal axis and this ray is parallel to each other, so separation between AB and OM will be equal to each other. So here in the place of OM we can put AB. So this equation will be AB upon A dash B dash, and it will be equal to OF2 upon A dash F2. This will be our second equation. So we got the first equation by triangle OAB and OA dash B dash, and we get second equation by MOF2 and F2 A dash B dash. Now, if we compare both equations, then we are seeing that the left hand side of equation 1 and 2 is similar to each other. So right hand side of this equation will also be equal to each other. So from equation 1 and 2, we can write that OA upon OA dash will be equal to OF2 upon A dash F2. So we are getting this form. Now, if we put all the values that we are right here, if we put all the values in that particular equation, then we will get another part. We know that OA is equal to negative of U, OA dash will be equal to B, OF2 will be equal to small f, and F2A dash or A dash F2 will be equal to V minus F. So we are putting in this equation. So OA will be equal to minus of U, OA dash will be equal to V, equal to OF2, which is equal to F, and A dash F2, which is equal to V minus F. Now, if we cross multiply, then minus U will be multiplied by V minus F, and V will be multiplied by F, so it will be VF Now if we open this bracket, then UV plus UF will be equal to VF. Now if we divide both sides by a term U, V and F. To simplify this, we have to divide both sides by U, V and F. So we will get UV divided by UVF plus UF divided by UVF. Yes. So if we divide both sides by UVF, then here we have UV upon UVF plus UF upon UVF and VF upon UVF. So UV will be cancelled out by U and F also will be cancelled out by U and F. VF also be cancelled out by VF. So we will remain here. The remaining terms will be minus 1 upon F plus 1 by V equal to 1 by U. If we rearrange this, if we put 1 upon F from the another side and 1 by U, if we get this side, then we will get 1 upon V minus 1 upon U will be equal to 1 by F. If we rearrange it, then it will become 1 by F is equal to 1 by V minus 1 upon U. So this will be our length formula, which is related by terms focal length, image distance and object distance. Thank you.